Welcome back. In the last lecture session, we have learnt about selection sort, the procedure to be followed for selection sort, and we have seen an example, and also we wrote a program and executed that program to see how it works. In this class, let us learn about another important sorting algorithm called merge sort. The number of steps to be followed appears to be very simple. There are just three steps here. First one, if it is only one element in the list, it is already sorted, return. So this one we followed even in selection sort. If the number of elements in the list is only one, it is already arranged. The second step, divide the list recursively into two halves until it can no more be divided. The merge sort is also called as divide and conquer technique, where the whole list is divided into smaller lists. So first, if the number of elements in the list equal to 8, it will be divided into two lists, each of size 4, 4. And again, that list will be further divided. Elements of 2, 2. Again, it will be divided with only one element in the list. So the list will be broken till it finds it will be a very small list, or the list consists of only one element. Then the third step is to merge the smaller list into a new list in sorted order. In the second step, we have we have split the list, we have divided the list, and in the third step, the divided list is merged with the first one. Only two elements are merged to become a two element list. While merging, we arrange it. So that is the whole technique behind merge sort. Let me explain you with an example. Let us take this one. So on the left side, I have the divide. Dividing the list, a big list is given, it is divided into small. And on the right side, I have combining the list. This is called divide and conquer. This is my example: 14, 33, 27, 10, 35, 19, 44, 42 and 44. It is an unsorted list. So totally there are 8 elements. In the first iteration, what I do, I divide it into two halves. So as it is 14, 33, 27, 10. It is the left sublist. 35, 19, 42, 44, right sublist. Again divide this one. The left sublist is divided into two, 14 and 33, 27 and 10. So two separate sublists. And the right sublist is again divided 35, 19, 42, 44. It's a simple technique. Again, in the last step, I am further dividing it. This 14 and 33 become two separate lists with only one element in the list. 14, 33, then 27, 10, 27, 10, 35, 19, 42, 44. So now at the beginning, when I started with a raw list, totally there are 8 elements and the number of list is only 1. At the end, after doing all division, I have how many lists? 1, 2, 3, 4, 5, 6, 7, 8 lists, and each element in the list is equal to 1. Only one element in the list, totally there are 8 lists. This completes the first stage called dividing the list. Next is merging the list, which is called the combining procedure. At the time of combining them, arrange them. So a small list is taken, the numbers are arranged internally. It will be only two numbers, they are arranged. Now you take 14 and 33, two lists. So left list and right list, and arrange them. So that the first element will be the smallest element and the second one will be the largest element. So it is locally arranged by just comparing. So you compare 14 and 33, which is smaller, which is bigger, you arrange them in order. It is an ascending order, in fact. Next is 27, 10. So in 27 and 10, 27 is bigger, 10 is smaller. You arrange them locally. So bring 10 to the first position, then 27. Then 35, 19. So bring 19 first, then 35. The last one, 42 and 44. No need of interchanging. You retain it as it is. So this is the first stage of combining, where single list will be converted into list of two elements. Elements of one with one element is converted into list of two elements. And in the next stage of combining, this two element list will be taken and will be formed a list of four elements each. Okay, so now my new list is 14, 33, 10, 27. These are my two lists, left sublist and right sublist. You combine these two. Now 14, 33, 10, 27. Among these four, which is the smallest? 10. Bring 10 to the first position. Which is the next one? 14. Then 27. Then 33. Do comparison, do swapping wherever necessary, and arrange it locally. And in the same way, use the rightmost two lists, 19, 35, 42 and 44. Arrange them locally in ascending order, 19, 35, 42, 44. Now here in this list, I have combined and formed two lists, each with four elements. And the last stage is to combine all elements in the list and to form a single list whose length is equal to the original list number. Now it is 10, 14, 27, 19. With 19 is the smallest, you bring it here. Then 27, 33, 35, 42, 44. Algorithmically, this appears to be very simple, and the internal sort algorithm which is used in Python modules, the one L dot sort, etc. we were using, they use us internally this merge sort. Let us see how this works by writing a program in the Python interpreter. Let me open the Anaconda interpreter. This is my program. I have written two functions, merge list and merge sort. One for dividing and one other one for combining. You see here, this is my main program. My main program has just two lines. In the first line, I input the list. L equals 14, 33, 27, 10, 35, 19, 42 and 44. The same example that I have shown here is taken even in the example program. And finally, print the same list. Merge sort L. So first what I am doing, I am calling the first function merge sort here. And I have inputted my raw list here. L equals this much, and this is my actual parameter, which is the input list is the actual parameter, and this is the formal parameter. So now what I am doing, this merge sort is used for dividing purpose. You see here, if length of the input list is less than or equal to 1, return input list. That is step number 1 in merge sort, where if the length of the list is less than or equal to 1, that clearly indicates numbers are already arranged. It has only one element. One element means it is already arranged. Otherwise, it enters this else loop body, and here it performs the division operation. It creates the sublist in the same way as the binary search, in the same way as successive approximation, A to D conversion. Here midpoint is identified. Midpoint equals length of input list divided by double slash. Double slash is an integer division, divided by 2. What is the length of the list? Length of the list is 8. 8 divided by 2 is equal to 4. Left sublist consists of 4 elements, and right sublist also consists of 4 elements. Okay, so what I am doing here in merge sort, merge sort is the function here. it will be called again. It is a recursive call. Before calling, I am supplying to this one as input a new list. Here I am doing a slicing operation, list slicing. For the left sublist, the first it is colon midpoint. Midpoint is 4 and colon is 0. So the left sublist is taken and it will be inputted to merge sort. In the same way, for right sublist, the initial point is midpoint and the last point is the default value, which is the index of the last element. So that means for left sublist it is 14, 33, 27 and 10, and for the right sublist it is 35, 19, 42 and 44, which are again inputted to this merge sort so that it will be further divided. So each time this division operation is performed by calling this merge sort. So after whole division is over, if the length of the list is less than or equal to 1, means if all elements are split, the list is equal to a single element list, then we call this merge list. By supplying the left sublist and right sublist, I will call this merge list. So the very first input here is only one element in the left sublist and only one element in the right sublist. And you create new indexes for merging. This is used for the purpose of combining. So this function is used for combining, it will merge. So initially I create the index for the left sublist and right sublist I and j, and I have to create a new list. This is an empty list I am creating result, and each time I am appending. So you see here, while if I is less than the length of the left sublist and j is also less than the length of the right sublist, so the indexes for the new sublist must be less than the one which is already supplied from the merge sort. Then what I have to do for the left sublist, if the first element is less than the second element, you append it. So result dot append left sublist I. So append is a built-in method which is used for a list. The element ith element will be appended and the index will be incremented. Else, that means after performing this operation, if comparing the left element and the right element, if the right element is the bigger, then append it as a right element in the list. So while merging, if we have a smallest number, put it to the left, append it to the left and increment I. If it is bigger, then put it to the right and append j. So after running this is my while loop. This while loop is repeated till all the elements are combined. Next, you append, this is called again the new list. The result is formed by putting all the left sublist on the left side and all the elements of the right sublist on the right side by using index I and j. So this is the last step. So this step. So these four and these four, and they are put together to form a single list, single arranged list. That's what is performed in these two statements. So result plus equals and result plus equals. Okay, so this is about the merge sort, where I am using first dividing by using merge sort and combining by using merge list. Let me run this program to see the result. Okay, you see here, after arranging, so I will get 10, 14, 19, 27, 33, 35, 42, 44. So here also, so I can use, you see here, if left sublist is less than or equal to right sublist, instead of this one, if I use greater than or equals, I can arrange them in descending order. So same algorithm can be used even for arranging numbers in descending order. This is one of the important algorithms, merge sort. Okay, let me stop here. Thank you.